Some of these more difficult ones just mean you have a little bit extra step. So I'm going to do an example with each of them. And you can do this on page 734 or 751. So if I said find the last term in the expansion of 3x minus 2y to the 16. Yeah, I'll do 16. That's a big number. What makes this one a little bit harder is which one is the last term. Which term would you find?
15.
Term 15? Term 16? Term 1? No, term 1 won't be the last one. How many terms are there? There would be 17 terms. So which one is the one you want to find? You want to find term 17. K then would be 16. Now, if you know how these work, you could do a shortcut for this one, but if you use the formula, it's going to be 16 choose, because you get the 16 from the end, 16 choose 16. First term to the 16 minus 16. Second term to the 16. Figure out each of these separately. 16 choose 16, that's mental math. You can do that one. 1. This one you can do mental math. This is going to be 3x to the 0. 1. 2 to the 16. Negative. Will it be negative or positive here? Positive because it's an even power. And 2 to the 16 is 6. 5, 5, 3, 6. And then you'd also have y to the 16. So now you can multiply all those together, which there's really not much work to do.
It's only that much.
I know, it seems like it should be much higher, eh? And that would be the last term. If you think about the Pascal's triangle, does it make sense the last one always has a 1? And does it make sense that there would be none of this one, there's none of them, so like, I'll put another 1 there to represent there's none of that one. And it's just the last one to the power of 16. So you could use that as a shortcut, but not needed. So what makes the last term a little bit tricky? You need to know how many terms there are to say you're finding term 17. So a little bit more work. Middle term. Middle term questions only work if you have an odd number of terms. Because if you only had 4 terms, which number's in the middle? You have 2 on this side, 2 on this side. There's nothing, you can't say specifically one's in the middle. But as soon as you get 5 terms, I'm not going to demonstrate here, it could be dangerous. There is 1 in the middle. Okay? How many terms do we have here? 7 terms. Number 1 mistake with middle term questions is people find term 3. If you have 7 numbers, which is the one in the middle? 4, right? 1, 2, 3, 4, 5, 6, 7. 4 is the one in the middle. 3 on either side, 1 in the middle. So you would have to, this is what makes it a little bit harder. You have to know you're finding term 4. As soon as you discover you're finding term 4, it becomes an easy question, just like example 3, plug things into your formula. So what's my n? My n is 6. 6 choose. What's my k? K would be 3. A is 2x to to the 6 minus 3. B is y to the 3. Do each of these things separately. 6 choose 3, mental math, anybody? Is that right? Double check with your calculator. 2 to the 3 would be 8x to the 3. Again, do each of them separately to simplify first. And then we can multiply this together. 20 times 8, 160. What do we have for variables? We have an x cubed, y cubed. There's our middle term 4. Yes.
Will they ever ask us, like, if there's only 6 terms?
To find the middle one? No.
No.
Because there's no, if there were 6 terms, right, there's no 1 in the middle.
Yeah.
So if they ask you a middle term question, you'll always have an odd number. It's always going to be 1 more than half of that. So if you take 6 and divide by 2, you get 3. It's going to be 1 more than that. Okay. And now those, so last term and middle term are a tiny bit more difficult. The next question is the next, is another level of difficulty. And these questions look like this. Find the term containing an x to the 9 in the expansion of, and we're going to use 3x squared minus 2 divided by x to the 9. And I'm going to show you how to do this, and some of you are going to forget. And on the test, you're going to be like, how do I do this again? And the best I'm going to tell you exactly what I'm going to tell you right now. I'm going to be like, well, I guess you could find all 10 of them, simplify all 10 of them. One of them is going to have an x to the 9, and that's the right answer. But that's a lot of work. So we're going to want to find a shortcut for this. And what we're going to start with is putting everything into the formula that we know. Okay? So here's my formula. I'm going to write out the formula first. Okay. There's my formula. Do I know the term? No. Do I know something about the term? Yes. It's going to be some number with an x to the 9. I know whichever my answer is, it's going to have that. Do I know n? Yes, the n is 9. Do I know k? No. So I'm going to keep the k there because I don't know. Do I know a? Yes, it's 3x squared. 9, I know n, but I still don't know k. Do I know what b is? Yes, it's going to be negative 2 over x. This is what we know and what we don't know. So basically there's 2 things that we don't know. We don't know the number in front, here, and we don't know k. The strategy that we're going to do is we are going to only use because the only hint that we have, I'm going to circle it in purple, the only hint that we have is the exponent is 9. That's our only hint. So what we're going to do as a strategy is we're going to ignore all the numbers in front, or all the coefficients. And then we're going to use the exponents to find k. So if I do that, I'm just looking at x and the exponents. The left-hand side, if I ignore the front, it's just x to the 9. 9 choose k is going to be a number. I'm going to ignore it. This 3 is going to go to an exponent. It's going to be a number. I'm going to ignore it. On this side, I'm just looking at x's and exponents. And there's x's. This x would be in the numerator, right? Because this is like over 1. And this other x is in my denominator. Can you see that in your numerator, this x squared is going to go to the 9 minus k. You're going to have 18 minus 2k. That's how many x's you would have in your numerator. And in your denominator, how many x's would you have? It's going to go to the exponent of k. It would have an exponent of k. And now it goes back to our exponents and logs unit. How do you solve exponential equations if you have the same base? Well, first, you would want to get both of them to be a single power. So what's my exponent law when I'm dividing? I subtract 8 minus 2k minus another k will be 8 minus 3k. And then we have this strategy. So, as a result, the 9 has to equal 18 minus 3k. Could you solve this? Well, I'm going to move the 3k to this side. I'm going to move the 9 to this side. Divide by 3. And I figure out that k is 3. Next part of the strategy. Now we can find the term. Once you found out k is 3, you know that the answer is going to be term 4. Term 4, if we find term 4, it should have an x to the 9 when we're all done and simplified. If it doesn't, we made a mistake somewhere. So now I go, I find term 4. Well, and choose k. My n hasn't changed. Right? If you go back, I'll just rewrite the thing here. It was 3x squared minus 2 over x. Right? This was our original equation. It had 10 terms. You could have found all 10 of them and simplified all 10. But we know the answer is supposed to be term 4. If I want to find term 4, then I would have 9 choose, what's k? 3. My first term is 3x squared to the 9 minus 3. And my second term was negative 2 over x to the 3. Go to our calculator. 9 choose 3 is 84. Well, I thought I went to the carnival. 3 to the power 6 is 729. X squared to the power 6 would be x to the 12. Negative 2 to the power 3 is negative 8. X to the power 3 is x cubed. Do each of them separately. Now we can multiply our numbers together. So 729 times 84 times negative 8. And we get negative 489,888. And look at our x's. You have x to the 12 in your numerator and x cubed in your denominator. Do you see that they'll simplify to be x to the 9? An English lesson. Okay, I'm going to go back to the beginning for a second. Everybody, give everybody a second. Everybody good? Here's our English lesson for the day. If it says find the term, you actually have to find the exact numbers of the term. We had to find term 4 and exactly what it was equal to. If this question says find which term, you were done at term 4. It's term 4. Didn't ask me to find it. Okay, so be careful. Because if it says find the term, and you just say term 4, I'm done, move on, you're going to lose the last 2 marks for actually figuring it out. If it just says, hey, which term has an x to the 9? You're like, oh, term 4, I'm done. So we have to be careful with the English. We read things carefully. Do they want me to find everything? Or do they just want me to find where it is? So what was our strategy? I wrote the strategy in blue. We put everything that we know, and the only hint they gave us is that it had an x to the 9. So we ignore all the numbers in front and just use the exponents to find k. So you see how on this side I have x to the 9, and on this side I ignored all of the numbers, but looked, how many x's do I have in my numerator? How many x's do I have in my denominator? And I had to do a little solving. Sometimes these questions, I'll give you one that there's a shortcut right after this. And then we'll go to our last example. Sometimes you can do them really quick. Sometimes you can just look at it in mental math and find the answer right away. This one we had to do some algebra. Because our x's in our numerator were x to the 18 minus 2k. Our x's in our denominator were x to the k. There are some people who like to just guess and check. They're like, I'm going to guess 4. If I guess 4, there's x to the 10 on the top, x to the 4 on the bottom. What does that give me? X to the 6. Ooh, that's not enough. So then I would try 3 to have more on the top, and you find it really quickly. Some people like to guess and check and find them really quickly. There was one exam where the exam said, find it algebraically, so then you had to use this method. Okay. Then after you found k, now it becomes an easy question. Now you just have to find the term. You know if k is 3, it's term 4. We just plug things into the formula. A lot of people like binomial theorem because once you know what to plug in, it's just a matter of just crunching the numbers out. And to be safe, when you're doing the formula, do each of these 3 separate, simplify them first, then put your numbers and variables together, and you'll be fine. So I said I'd give you an example of one this one is like the hardest the which term gets. You have to do some algebra. Sometimes they're easier, so here's an easier one. Find the term. I'm going to leave a space there because I'm going to make up numbers here. Find the term containing x to the 8 in the expansion of 3x squared minus 2y to the 7. I go to my formula sheet, and I'll write this out for now, just kind of nice to see what you would have on your formula sheet. There's your binomial expansion. What do we know? We know that it's supposed to have an x to the 8. My n is 7, so I have 7 choose. I don't know what k is. Okay. Now, put your pencil down. Look at this. Tell me what k is. You should be able to this is one that's this easy. You can just look at it and say what k is. 3. How do we figure out that k is 3? That easy. It is readily, you look at it. Do you see that the only place there's x's is here? The only place there's x's is here. We want x to the 8. What has to be in that circle to make an x to the 8? That circle has to equal 4. So then your mental math, you're like, oh my goodness, 7 minus something is 4. and then you get k. Like, if this has to equal 4, then k has to equal 3. Sometimes you can just see it right away. And that happens when they have these term-containing questions, but there's only the x in one spot. The last question I did, I put x's in both spots. I had one in denominator, one in the numerator. Much more difficult. This one, x is only in one spot. If I said, find the term containing y to the 5, you would know that k has to be 5. Because the only place there's a y is here. And the only way to get y to the 5 is if k was 5. Yes.
Isn't the last one is like just a binomial?
Isn't the last one, this one that we did?
Yeah.
It's not a, well, it has an expansion. This is a binomial inside,
Yeah.
but it has the power of 9. There's going to be 10 terms when you get your final answer.
Yeah, but since there's only one like thing, doesn't that make it like different? Only one variable?
There's only one variable. Yeah, technically this is a rational expression, not a binomial. Binomial is 2 terms, but binomial we tend to say 2 terms without x's to the negative 1. But those aren't like terms, you can't put them together.
Yeah.
So we still have to deal with it the same way. And then, okay, so this one, I'm not going to go further, but it's really easy to see that you have to find term 4. And this one says find the term, so you'd have to keep going, but that part is the easy part. The hard part is finding out which term it is. And I find that the hardest questions for students are these ones that say, find the constant term in the expansion of 5x cubed minus 2 over x to the exponent of 12. I'm going to take out my highlighter. And if you don't know what this means, you're going to be screwed. Okay? In fact, some of you will put your hand up on the test and say, what is constant term? And I'll tell you, when you go home tonight, watch this video again, because I warned you that you're going to forget this. And I warned you that if you ask that question on the test, I'm going to say, well, find them all. There's 13 of them in this case, right? Find all 13, simplify all 13, and maybe when you look at all 13, one will be like, oh, that must be the constant one. That's the best I can do. That's a lot of work though. Okay? A constant term, what does that mean? It's just a number. In other words, there's no variable. There's no x's. Algebraically, with powers, that means you have x to the 0. And as soon as you realize that it is x to the 0, it is the same question as we just did that said find x to the 9 in the expansion. Find the term containing x to the 0 in the expansion of this. So when we think of our formula, and I'll write it out again in blue. We know that our term has an x to the 0, because all the x's would go away. We know that n is 12, we don't know k. We know that a is 5x cubed to the 12 minus k, and we know that b is negative 2 over x to the k. What was our strategy? I'll write it out in blue again. Temporarily ignore the coefficients use the exponents. To find k. So on this side, we ignore the number in front. It's a good thing we can ignore it because we don't even know what it is. And just look at x and the exponent. On the right-hand side, there are x's that would be in your numerator. There are x's that would be in your denominator, right? Because this is over 1. The 12 choose k will be a number. Ignore it. The 5 to some exponent will be a number. Ignore it. In the first set of brackets, you're going to get, right, exponent law multiplied 12 times 3 and k times 3. 36 minus 3k would be your x's in your numerator. Second one has an x in the denominator. There will be k of them. Exponent laws means that dividing with the same base, I can subtract. This will be 36 minus 3k minus another k will be 36 minus 4k. So 0 would have to equal 36 minus 4k. I can solve it, but you probably can see that the answer is 9 already. K is equal to 9. And if k is 9, we need to find term 10. And if we didn't make a mistake, all of your x's should cancel out and you should get a constant term. So let's see if that happens. Term 10. Again, I'm going to rewrite the equation. It was 5x cubed minus 2 over x to the 12th. So n is 12. K was 9. 12 choose 9. A value is 5x cubed to the exponent of 12 minus 9. And the b value is negative 2 over x to the exponent of 3. Do each of these separately. Twelve choose 9. Put it in brackets. That's 220. 5 cubed. That's 125. X cubed cubed is x to the 9. Oh, I made a typo. Does anybody notice the typo I made? K was 9. And I wrote a 3. What do you think I was doing in my head? Oh, I looked at 12 minus 9 and I was like, ooh, I can do that mental math. And then I accidentally wrote the 3. Math does that to your brain. If you start thinking about the next thing too soon, it's going to be like, it's going to throw wrong numbers at you. Negative 2 to the power of 9. I think that's 512. It is. And it's going to be positive or negative to an odd exponent. It's going to be negative, and x to the power 9, x to the 9. Put your numbers together. 220 times 125 times 512. It's going to be negative 140 8, and then 4 more zeros. Oh my goodness, that's a beautiful number. And then do you see that your x to the 9s would just go away? You have x to the 9 in your numerator, x to the 9 in your denominator. And so your final answer has no x's. That is what makes it a constant term. I'm trying to think of some silly way to remember how you're going to remember this. If you're in a constant relationship, so you don't have an x. Right? Maybe, I don't know.
Not as good as sexy.
For the frogs are sexy, that was the best one. All right, so those are our extra questions.